Continuing to solve our quadratic equations, and today we're going to solve by factoring. So a little refresher on factoring. So our quadratic expressions are usually in the form ax squared plus bx plus c, right? So we have the a in front of the x squared, the b in front of the x, and the c is the constant. So the first thing we could do is look to factor out a GCF, right? Greatest common factor. So anything that goes into both of these terms. So here, a 6 goes into both, and that's it, because this doesn't have an x term, this had an x squared. So if I take out the 6, 6x squared divided by 6 is just x squared, plus 24 divided by 6 is 4. So this is the factored form of 6x squared plus 24. All we had to do is take out a GCF. If a is 1, like x squared plus 11x plus 24, right? No number in front of the x squared. We're going to look for the numbers that multiply to the c value and add to the b value. So what I tend to do is I take the number I'm multiplying to, and I'm going to make a list of its factors. It's positive, which means it could be a positive and a positive, or a negative and a negative. The middle term being positive tells me it's going to be positive, positive. So I'm going to say 1 and 24, 2 and 12, 3 and 8, 4 and 6. So out of this list, the one that added to 11 was 3 and 8. So my factored form would have been x plus 3 and x plus 8. Obviously, if you recognize the numbers, you don't have to do this. But if you're stuck and you can't see it, I would do this, and I would go in order. I would try 1, 2, 3, 4, 5, 6. Keep going, and only write the ones down that went in evenly. If there are 4 terms, we can factor it by grouping. And when we say grouping, we mean we're going to group the first 2 terms together and the last 2 terms together. We're going to take out a GCF of each set. So out of the first set, the GCF would be x squared. So if I were to take out x squared from these, x cubed over x squared is x. 5x squared over x squared is 5. Out of the second set, I could take a 3 out of both of those. So if I take 3 out, 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. If we've done this correctly, we should have a matching pair of parentheses. And if that's the case, that is one of the factors. The other factor is the leftovers, the x squared and this positive 3. So that would be how we factor when there are 4 terms. If a is not 1, we can multiply a by c first. So 2 times 63 is 126. And then make the factors of that add to b. So this would be 1 and 126, 2 and 63, 3 and 42, 4, nope. Oops. 4 does not go in, 5 does not go in, 6 and 21, 7 and 18, and oh my goodness, 7 and 18 are the ones that add to 25, right? So we had to go quite far to get that. What we're going to do is we're going to rewrite this now with 4 terms, and we're going to replace the b with the 7 and the 18, right? 7x plus 18x is 25x. So I'm going to replace this here. I'm going to say it doesn't matter which one you put first, but if you know that like it's going to be easier to find a common factor with the 2 and the 18, you can put the 18 first before the 7, whatever makes most sense to you. Oops, not what I wanted to do. Okay. So this is going to be rewritten as 2x squared. I'm going to put plus 18x plus 7x plus my 63. So all I've done is taken this 25 and break it down into 2 parts. Now I have 4 terms. I'm going to factor by grouping like I just did in this last problem. So these 2 have a 2 in common and they have an x in common. So 2x squared divided by 2x is x. 18x over 2x is 9. If it helps you to put it under it so you could see what you're dividing, do that. Right here, I can take a 7 out of both. So when the 7 comes out, 7x over 7 is x. 63 over 7 is 9. They matched. So x plus 9 is one factor. And leftovers, 2x and a positive 7 are the others. We can also look for a special pattern. So the difference of two squares, which we might call dots, is when you have something squared minus something squared, right? This squared is x, this squared was 7. So that product is always going to be, right, if it's a squared minus b squared, it's going to turn into a plus b times a minus b. So if this was x and this was 7, that's going to be x plus 7, x minus 7. So now to solve by factoring, the equation must be equal to 0. We're always going to check for a GCF first. We're going to factor according to the type of equation that it is. And then once we've factored it, we set each of the factors equal to 0 and solve. It's called the zero product property. The fact that 0 times anything will give you 0. So as long as one factor equals 0, the whole thing equals 0. So for example, 1, solve by factoring. So it looks like there's only two terms here. I do have something in common between them, so I'm going to take out a GCF. So I'm going to take out an x, and when I do that, I'm left with x minus 6. Oops, lost my marker. So now my factors, even though it doesn't look like this is in a set of parentheses, this right here is a factor all on its own. So x would equal 0. And then the other factor, x minus 6, would equal 0. So if I add 6, x would equal 6. So x equals 0 and x equals 6. For b, again, I only have two terms. And I'm not going to divide both sides by x because that would make the x go away. Instead, I'm going to move the 8x over so it's equal to 0 because anytime we're factoring, we want it equal to 0. Now, my common term is x, so that's going to come out, but it's not going to go away. So we're going to have 3x minus 8. So now we're going to have this again, the x equals 0. And I'm going to have 3x minus 8 equals 0. So this we're going to have to do a few steps to solve. Add the 8, divide by the 3. So x would equal 0, and x would equal 8/3. All right, there's one here for you to try. You can pause. The answers are posted in Google Classroom in the blank notes. So for example, 2. We need it equal to 0. We're going to solve by factoring. So I'm going to minus 3. And because a is 1, I could just look at the two numbers that multiply to 20 and add to negative 12. So that's positive, meaning negative times negative to give me a negative. So negative 1 and negative 20, negative 2 and negative 10. Oh, it's already there. Negative 2 and negative 10. So that's x minus 2 and x minus 10. That's my factored form. So if I set each of these equal to 0, right, we're going to get x equals positive 2, and we're going to get x equals positive 10. For b, we have quite a lot to do. We're going to minus 3x and minus the 8. So it's going to be x squared plus 2x minus 48 equals 0. So now we have a negative number. So one's positive, one negative. The bigger one has to be positive to end up with positive. So negative 1 and 48, negative 2 and 24, negative 3 and 16, negative 4 and 12. 5 doesn't go in. Negative 6 and 8. There we go. Negative 6 and 8. So x minus 6, x plus 8. Set each of them equal to 0. So x would equal 6, and x would equal negative 8. There's one here for you to try. You can pause. Answer to post in Google Classroom. Okay. So for A, it looks like I don't have a bx term, but I do have 2x that's being squared here, and I have 9 that's being squared here, and it's minus in between. So this is our dots, our difference of two squares. So this is going to be 2x plus 9 and 2x minus 9. And if I set it equal to 0, we would have 2x equals negative 9. So x is negative 9 halves. 2x equals positive 9. So x equals positive 9 halves. You might notice you could have also solved this one by square roots. That's fine, but because the directions specifically said solve by factoring, that's what we're going to do. There will be times where we want to factor something as opposed to just getting the x values, so we need to know how to do this. All right, for this next one, if I were to move everything over so it's equal to 0, minus 3x minus 1, 3x is going to cancel out, and I'm left with minus 36. So this is really x being squared, and this is really 6 being squared. So that would be x plus 6, x minus 6. Setting each equal to 0 gives me x equals negative 6 and x equals positive 6. All right, there's one here for you to try. You can pause. Answers are posted in Google Classroom. Example 4. So we have to get everything equal to 0. We always, I should have said this earlier, always want the term with x squared to be positive. So I would not minus 3x squared from both sides here, even though that's less work. We don't want a negative a. So I'm going to keep this and I'm going to move both of these over. So we're going to get 3x squared minus 23x minus 8 equals 0. So this one has an a value in front. So we're going to do 3 times negative 8 to get negative 24. We want a negative number, so the bigger has to be negative. So 1 and negative 24 is already it. That's our pair. So we just have to figure out, do we want to put the 1 with the 3 or the 24 with the 3, the 1 with the 8 or the 24 with the 8? This one's really not going to matter either way. I'm going to do the 1 with the 8 just to show you guys something. All right, so we're going to do 3x squared minus 24x plus 1x minus 8. So out of these, we could take a 3x, and I'm left with x minus 8. Here, there's nothing that comes out of them. And when nothing comes out of them, technically a positive 1 comes out of them. You could always divide something by a positive 1. It doesn't change it. So taking a positive 1 out still leaves me with 1x minus 8. And my parentheses match, so I know I did that correctly. So x minus 8 is one factor. 3x plus 1 is the other. And now we're going to set them equal to 0. So we're going to get x equals 8 minus the 1, 3x equals negative 1, which means x equals negative 1/3, and x equaled 8. For my second equation, I'm going to minus the x and add the 4. So we're going to get 5x squared plus 9x plus 4 equals 0. So 5 times 4 is 20. The positive 20, positive 9, so everything's positive. 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5. 4 and 5 is it. That adds to 9. So I'm going to keep the 5 with the 5. So I'm going to do 5x squared plus 5x plus 4x plus 4. So the first two both get a 5x, and I'm left with x plus 1, right? Dividing a 5x by a 5x gives me a positive 1. I can divide these by 4, right? A positive 4. 4x divided by 4 is x. 4 divided by 4 is 1. Don't forget that you need that plus 1 there. It doesn't cancel out. It turns into 1. So my factors are x plus 1 and 5x plus 4. So we're going to have x plus 1 is 0 and 5x plus 4 is 0. I'm going to solve this one first. So 5x would equal negative 4 and x would equal negative 4/5. And here we just minus the 1, so x would be negative 1. So here's one for you to try. You can pause. Answers are posted in the Google Classroom. So example 5. The length of a rectangle is 7 inches less than twice the width of the rectangle. So we're going to first write a quadratic function that represents the area in square inches of the rectangle for a given value of w. We know it's going to be a of w equals, if the width is w, right, length times width or width times length, the length is 7 less than twice the width. So twice the width, take away 7. So what this would really be is a of w would equal 2w squared minus 7w. So that's my equation. Part B, if the area is 60 square inches, what is the width of the rectangle? So if a of w is 60, what is w? So what we're going to do here is we have a quadratic equation. We're going to get it equal to 0 by minusing the 60. And we have to factor this. There's no GCF here, right? 2 does not go into everything. So I'm going to have to factor where a is not 1. So we're going to start with 2 times negative 60 is negative 120. We want to add to a negative number, so bigger numbers are negative. So 1 and negative 120, 2 and negative 60, 3 and negative 40, 4 and negative 30, 5 and negative 24, 6 and negative 20, 7 didn't go in, 8 and negative 15, that's our pair. 8 and negative 15 adds to negative 7. So we're going to have 2w squared plus 8w minus 15w minus 60. So 2w comes out of the first two, left with w plus 4. Take a negative 15 out of these, which is w, and then negative 60 over negative 15 is plus 4. So that's 2w minus 15 and w plus 4. We know that w plus 4 is going to give us a negative answer, and I can't have a negative width, so I'm going to ignore that one. I'm going to focus on the 2w minus 15. So 2w would equal 15. W would equal 15 divided by 2, or 7.5. Right? 7.5 in inches. Because it was a word problem, we use our units. And for the last example, the quadratic function, g of x, can be written in the form of this. What are the values of a, b, and c? So basically, they just want us to factor it. And since there is a number out front that tells us there's probably a GCF in here that we could work with. So if I start with that, we're going to take out our GCF. And our GCF looks like it could be negative 4. So when I divide everything here by negative 4, that's going to become negative 3x, and that's going to become negative 40. Now I want to factor what's left inside here, right? So I'm looking for what multiplies to negative 40 and adds to negative 3. We can go ahead and make our list. I already know it's negative 8 and 5. So x minus 8 and x plus 5. So this is now this, right? They want to know what are the values of a, b, and c. So a is negative 4. B and C are interchangeable depending on how we have written them, but it's x minus what? X minus 8. So B is really a positive 8, right? Because it was written in x minus form already. And that means if this was x minus what to give us C, we're subtracting really a negative 5. So that would be my values of A, B, and C. And that is how we solve by factoring.